Good morning, everyone. In today's lecture, we'll discuss about the expectation or statistical averages. So basically, your statistical averages are your mean and variance. Today, we'll see the mean and variance formula for discrete random variable as well as your continuous random variable. So if we talk about mean, that is represented by mu x is equals to your expectation operator function x. So here your mu x is equals to summation x p capital X is equals to x. So mean can be defined as the probability mass function, that is p capital X is equals to x. Now if we talk about the variance, or we can say it as central moment. So here your variance, that is sigma represented by sigma x, is sigma x square is equals to your variance of x. So in terms of mathematical form, it is represented as sigma x square expectation x minus mu x whole square. So if we talk about in terms of the probability mass function, we know in probability mass function your capital X is equals to x. So your sigma x square is equals to summation x minus mu x whole square into probability mass function, that is p capital X is equals to x. Now coming on to the continuous random variable. Now in continuous random variable, your mean is represented as mathematically expectation x is equals to minus infinity to infinity x fx dx. Here the assigned real number with respect to random variable x is called as center of gravity of the area under the probability density curve of random variable capital X. Now if we talk about the variance, so your variance in continuous random variable is represented as sigma x square is equals to integrate minus infinity to infinity x minus mu x whole square fx dx. As we know that your random variable is divided into two, that is your discrete and continuous. So we have seen the mean and variance formula using regarding the discrete random variable as well as continuous random variable. Now coming on to the covariance. For the analysis of communication system, the statistical averages between two random variables is very important. So your covariance, that is for two variables, that is x and y, is represented as expectation x minus mu x into y minus mu x. So this is basically the expected value of the product of two random variables, that is x and y. Now if we expand this equation, that is covariance x comma y is equals to your expectation xy minus x mu y minus y mu x plus mu x mu y. Now since your expectation of x mu y is equals to mu y expectation x, that is equals to your mu y mu x. So we'll put mu y mu x with respect to it. So from here, and your expectation of y mu x is equals to mu x expectation of y. So we can put it over here and we can get finally, that is your covariance of x comma y is equals to your expectation xy minus mu x mu y. Now if we talk about that, we have considered a random variable x and y are continuous with joint PDF, that is denoted by small f. So your fxy, that is expectation of xy, is equals to double integrating xy fxy dx dy. Now this equation is called as your correlation of random variable x and y. So we can say that covariance is correlation function of random variable along mean x and y. Now again, if we consider that a random variable x and y are statistically independent, that it is uncorrelation, that means your mu x and mu y are not correlated. So it is represented as expectation of xy double integrating xy fx x into fy y dx dy. So we have, because they are statistically independent, so we have written it separately. Clear? Now if we integrate separately x term and y term, we get integrating minus infinity to infinity x fx dx, and integrating minus infinity to infinity y fy dy. Clear? Now you're integrating this is equals to your expectation of x, and this is equals to your expectation of y. So we can write it as your expectation xy is equals to expectation of x into expectation of y. Clear? We have seen that we have the product, so we will multiply over here. Now we know already that your covariance x comma y is equals to expectation xy minus mu x mu y, that we have solved earlier also. Now if we separate expectation of xy, so we can write it as covariance of x comma y is equals to expectation of x into expectation of y minus mu x mu y. Clear? Now we have separated both the terms regarding expectation of x and y. When we have separated, now we can say that mu x, that is the mean, is equals to the expectation of x, that is denoted by mu x. Same expectation of y will be your mu y. So we can say that covariance of xy is equals to mu x minus mu y minus mu x minus mu y. So it get cancelled and we get the answer as 0. So we can say that the covariance of independent random variable is equals to 0. Clear? So this was all about the statistical averages. Thank you.